Hello, my pre-calculus student. In this video, we are going to review the graphs of cotangent and tangent function. Now, these are the parent function of cotangent and tangent. They are very basic function. So let's start with the first graph. You can see on this graph, you can see that the y-axis is the symmetry of the graph. If the y-axis is the symmetry of the graph, this graph is the graph of cotangent function. Next, we are going to find the domain. So you can see right here that the graph of cotangent function does have vertical asymptotes, and the vertical asymptote, they are x equals 0, x equals pi, and then of course this is for one period, so it means that it's a multiple of pi. But first, let me talk about the period first. So the period is the length of one complete pattern of the graph. Now the pattern of the cotangent have three y value: y equal 1, y equal 0, and y equal -1. And then of course it just repeats itself again. So you can see on the left hand side y equal 1, y equal 0, and y equal -1, and the period is pi. So the domain, we go ahead and use the set builder notation, will be the collection or the set of all the x values such that we don't want to include the x value where the vertical asymptote are, so x cannot be equal to multiple of pi, so n times pi, where n belongs to the set of integer, or n is an element of the set of integer. So that will be the domain. Now let's move on to the range. The range, you can see right here that the graph of cotangent just stay between two adjacent vertical asymptotes. So therefore the range will be the set of all the y values such that negative infinity is less than y, y is less than positive infinity. Or you can say all real number on the y-axis. The y-intercept, so there's no y-intercept. But however, we do have x-intercept. So x-intercept for the first period on the right hand side from 0 to pi will be pi over 2. On the left hand side be negative pi over 2. So basically it's odd multiple of pi. So then we put x-intercept. So let's write them as an equation. So it will equal pi over 2 plus n times pi. So that will give us a multiple of pi, where n is an element of the set of integers. Vertical asymptote, so we can see out here that on the right hand side we have the vertical asymptote are x equals 0, x equal pi. On the left hand side be x equal -pi. So our vertical asymptote will be multiple pi. So n times pi, where n is an element of the set of integers. Symmetry is the point 0, 0. So the point 0, 0 of course it stay on our vertical asymptote, but we can compare the 2.1 of both the x-axis and one below the x-axis. So these are symmetry points. So therefore we can conclude that this function is an odd function. Okay, so let's move on to the next graph. Will be the graph of tangent of x. So this graph, the function is y equal tangent of x. First, let's talk about the period. So the period is the horizontal distance of one complete pattern of the y value. So I can look at the three basics. So value be y equal negative 1, y equal 0, and y equal 1, and of course the graph just repeats itself. So the period in this case will be pi. That will be the distance between two adjacent vertical asymptote. Now the graph does not have amplitude, so we can make a note that no amplitude, because the graph doesn't have y minimum or y maximum. It goes to the infinity. Now let's talk about the domain. The domain, again, you can see right here that the graph will take every single point on the x-axis. Okay, so I'm looking at three periods right here, except where the vertical asymptote. So for example, at x equal negative pi over 2, x equal pi over 2, and then the next one will be 3 pi over 2, or negative 3 pi over 2. So these are your vertical asymptotes. So how can we write them out using? How can we write them as a general formula using set builder notation? We say the domain will be the set of all the x values such that x cannot be odd multiple of pi over 2. So be pi over 2 plus n times pi, where n belongs or is an element of the set of integers. So that will be our domain. The range will be the set of all the y values such that will be all real number, because you can see right here that the graphs of the tangent stay between two consecutive. It does have it goes from negative infinity to positive infinity. So we will say the range be the set of all the y values such that negative infinity is less than y, and y is less than positive infinity. So we always list the smaller number first. In this case, we will list the negative infinity first. Now let's move on to the y-intercept. In this case, the graph does have y-intercept. The graph crosses the y-axis at the value y equals 0. The x-intercepts, the graph has many x-intercepts. So for every period, we will have one x-intercept. So the first one is x equals 0. The next one be x equal pi. So it means my x-intercept will be a multiple of pi. So will be equal n times pi, where n is an element of the set of integer. And symmetry is the point 0, 0, or the origin. So therefore the function is an odd function. So let's write down the summary for this video. Summary. In this video, we reviewed the graphs of cotangent function y equals cotangent of x and y equals tangent of x. Thank you for watching this video. I will see you in class. Goodbye.